So, the semi-major axis is A. It's half the distance of the major axis. The major axis is 18 units. A is not 18. A is not. It's half of the major axis. B is the semi-minor axis. It means it's half of the minor axis. So if you say that the minor axis is 8 units, B is 4. Okay? You have to know what A and B are. C is the distance from the center of the ellipse to a focus. You need to know C as well. We also have tons of expressions we came up with for how to find the vertices and the foci. And we know that C squared equals A squared minus B squared. All of those things are coming into one thing today, learn target H. So you have to know the vocabulary. You have to know those equations. And if not, you should be consulting your prior notes. Okay? These aren't that confusing, but you have to think some things through. Okay. Alright, so I have 3 examples to do with you first before I give you a new definition, and then we'll do the last one. So there's only 4 examples today. All of these are a little bit different. Here's what you need to do for learning target 8. In order to, you're writing equations for an ellipse. You're going to be given information, you're writing the equation. You need 4 things to do that. You need to know the orientation. That means is it horizontal or vertical? You have to know that. It depends on what your equation looks like. You have to know the center. If you don't know HK, you can't write an equation for the ellipse. You have to know A, which again is the semi-major axis. You have to know B, which is the semi-minor axis. So, you have to have those 4 things. Everyone good? For the first one, the center is at -2, -3. I need the center. That's awesome. I have H and I have K. That's fantastic. It says the length of the vertical major axis. That means I know the orientation. The major axis always tells you the orientation, so I know it's vertical. Perfect. The length of the vertical major axis is 8 units, so that means I should be able to find A. A is half of that, so A is 4. Perfect. And the length of the minor axis is 2 units. Well, if I know the length of the whole axis, I can figure out B, so B should be what? 1. All right. Well, then if you look at the formula for a vertical ellipse, you have the following. You have y minus k squared plus x minus h squared. Y squared is over a squared because a squared is always larger, always a major axis. That's the formula. We have all the pieces to fill it all in. So it's vertical, it doesn't have to be. You could change the order if you wanted to. Yes, it does. Alright. A equals 4. Half of 8. So, here's our equation. Y plus 3 squared over 16 plus x plus 2 squared over 1 equals 1. That's it, you're starting the equation. No, I just ready saying right equation. The y doesn't have to go in front. If you put an x in front of it, it would make sure it's under the y part. Are there any questions that have extra pieces? Good? Alright. example. The foci are located at negative 1, 0, and 1, 0, and A equals 4. Well, I know A, so I need to figure out three other things. I need to know B, and I need to know if it's horizontal or vertical. I can figure out if it's horizontal or vertical really fast by either thinking of what it would look like when I graph the foci, or doing a quick sketch. The foci way. So is right here, and negative 1, 0 is right here. So what's the orientation? Horizontal. So now I know the orientation, I know A, I still need the center and B. This is in the middle of the two foci, always. It's in the very middle. In this case, to figure out, if not, use the midpoint formula. But in this case, what's the center? 0, 0. Everyone good with that? Alright, well the only thing we're missing is B, so follow me here. There's no way to figure out B, right, from any of this information. There isn't a way to figure out just looking at this information. It's straightforward. I do have the ability to figure out C, though, looking at this. Remember, C is the distance from the center to a focus. So I can figure out C. If I then know A and C, then I know C squared equals A squared minus B squared, and I can figure out B. So I'm going to have to go through C first. So if you think about what it says with all your things, it says that we have H plus or minus C comma K for the foci, for a horizontal ellipse, right? So what does C have to be in this case? 1. Because H is 0 and K is 0, right? So we have to have plus or minus something comma 0 to get these 2 points. Well, we have negative 1 and 1, right? So C is 1. Everyone with me on that? Because the foci has the equation H plus or minus C comma K. We know the center is 0, 0. That's be plus or minus some number. Well, we have negative 1 and 1 as the foci. We know those. We're asking what? Seeking C would be. Well, C is 1, so I have C, 1 squared equals, A is 4, so equals 4 squared. So I have 1 equals 16 minus B squared. I solve that, I get negative 15 equals negative B squared, which means B squared equals 15. Now, before anything else, when I put this into the equation, I need it as B squared anyway, correct? So you can take the square root if you want to, but you're going to square it again in about 30 seconds. So I'm not going to do that. Alright? Is that okay? Alright, so for a horizontal ellipse, the equation is x minus h squared plus y minus k squared. The a squared is under the x, and the b squared is under the y, right? So my equation should be x squared, because x minus 0, over a is 4, so a squared is 16, plus y minus 0 is y squared, b squared is 15, and that equals 1. Not that these are crazy things that will be hard. You just have to keep track of a lot of things and think of all the things that you know about just to figure out the missing pieces. About the second example. Let's look at the third one. The center is at 1, 2. Well, that's nice. I have H and K. Perfect. Parallel to the x-axis. What does that mean? This ellipse is horizontal. It's parallel to the x-axis, then it has to be horizontal. And the ellipse passes through the points at 1, 4 and 5, 2. happens if you doodle a little graph here. These are going to be your vertices, or two of your vertices. So you might need to graph some of this, and that's okay. Just quick sketches, just so you have an idea of what you're dealing with. So our center's at 1, 2. We have a point at 1, 4. And we have a point at 5, 2. We already knew it was horizontal, so we already should have known that this distance was going to be A, and it was longer than this distance B. But we should really count and figure out A and B. So what is A? How long is A? 4. And how long is B? 2. So now I can just fill in the equation. Well, there's nothing else to do. If you had enough doodle, a little quick sketch, you may or may not have known that those are the vertices that you needed. So it's horizontal, so we're using the same equation we did on the last one. So I have x minus 1 squared over 16 again, plus y minus 2 squared over 4, and that equals 1. Questions on the curve? Alright, flip your notes sheet over then. I'm going to teach you one more vocabulary word, and then we'll use that to do the last example. Alright, so there's no questions about the first three. Okay. The eccentricity of an ellipse. It tells you kind of what the shape of an ellipse should be. If E is close to 0, that means the foci are going to be close to the center, so it's going to become not a circle, but more circular in shape. It's going to become less defined as like a definite oval. But when E is close to 1, foci are far away from the center, and then you have that clearly defined oval shape. It's all stretched out. Okay? E has the formula, which is why we have to go over this. It's C over A, the same C and A we've been talking about this entire section. So in order to do the next example, I have to know what that is, because it tells you what E is equal to. But E is just telling you, again, kind of how the shape is going to be. If E is close to 0, the foci are near the center of the ellipse. If E is close to 1, they're far from the center. All right. So there's one more example. I'll let you guys finish up writing. All right, here we go. Last example. Same concept, though, we're trying to write an equation. The center is at HK, as 3, 1, which is HK. Hilarious. Okay, so we know that. We're good. The vertical semi-major axis, which means we know that it's vertical. Semi-major axis is 6, which means that A equals 6, and E equals 1/3. So I am missing B. So we don't know what B is. We have a way to figure out what C is, and once we figure out C, we can figure out B. E equals C over A, which is equal to 1/3. And so I know that A is 6. So if I have c over 6 equals 1 over 3, what does c have to equal? 2. So now I know c. So I know c, and I know a, so now I can go through and figure out b. So 4 equals 36. So negative 32 equals negative b squared, so 32 equals b squared. So I'm going to write my equation for a vertical ellipse.
So would they have to do B and not A?
They could, but not in this situation. You wouldn't have enough information to figure it out. So my equation should be y minus 1 squared over 36 plus x minus 3 squared over 32 equals 1.